All right, good afternoon or good morning if you're on the West Coast. I'm going to do this is Richard Reister. I'm the Federal Program Manager for the Light Water Reactor Sustainability Program, and the next group of work scopes are related to and sponsored by the Light Water Reactor Sustainability Program. I'm going to give a brief introduction to the program to start out, and my plan is not to repeat that for all the work scopes, but just provide a little context for each of the different pathways as we discuss each of the work scopes. So the first one I'm going to start with is RC5, but again I'm going to go over the program introduction first. So the goal of the Light Water Reactor Sustainability Program is to develop the fundamental scientific basis to allow plants to operate in the long term. Initially, it's focused on licensing of 60 to 80 years, but it's really ultimately the economic viability of the plants in the long term is the focus. But it's a technology-focused program. So we're developing technologies and other solutions to enable long-term operation, improve reliability, and sustain safety. We've broken up the program into 4 technical areas. Material aging and degradation is the largest. It's roughly about half the program. Advanced instrumentation and controls technologies, risk-informed safety margin characterization, and then finally, reactor safety technologies, and I'll discuss each one of those in the next slide. So nuclear materials aging and degradation is understanding and being able to predict the long-term behavior of materials in nuclear power plants, and that includes detecting and characterizing aging degradation. So detecting would be non-destructive examination methods. The advanced instrumentation, information, and controls technologies is addressing the long-term aging and obsolescence of the existing INC technologies through a strategy for long-term modernization. So really it's moving toward digital technologies and doing that in a way that results in cost savings for the plants. You know, plants aren't interested in just changing for change's sake. There needs to be a business case for that. The risk-informed safety margin characterization is developing a set of tools that can be used and applying those tools to analyze the safety margins of plants as they age. The major tools is RELAP 7, which is a thermal hydraulics code, Grizzly aging degradation, material aging degradation code, and we also have a Raven code, which is related to simulation controller code to control a simulation scenario. We do have a 5th pathway that we don't talk about too much, but it's really to cover some cats and dogs, systems analysis and emerging issues related to issues such as flexible operations and water usage issues that we've dealt with in the past. Some use of lithium is another example of what we've done here, but they're kind of one-off projects. And we don't usually have any UPs related to these areas. And then the final area is reactor safety technology, and this was really to address safety issues that emerged in response to the Fukushima accident. And so we're looking at a few areas in terms of technologies for accident tolerant current and future reactors. Severe accident analysis, and we'll talk about that later in that area. So those are the different areas. So this first call, RC5, is in the materials aging and degradation area. So this area is broken up really into metals, concrete, and cables, and then finally the 5th area, which is really mitigation and repair or replacement technologies, mostly focused on metals. But I'll say repair technologies for repair of cables in situ. In the metals area, I think these are pretty well known. They're focused on irradiated stress corrosion cracking, high fluence phase transformations and swelling of core internals, reactor pressure vessel embrittlement, crack initiation in nickel alloys, cast austenitic stainless steels, and environmentally assisted fatigue. In both the concrete and cable areas, well, actually in all of these areas, we coordinate very closely with the Electric Power Research Institute and the NRC. But in the concrete and cables areas in particular, they're fairly new in terms of the long-term degradation modes, and we have joint research plans with EPRI and the NRC in these areas. So I think that's the summary. So what I'm going to do is pass the torch to the technical point of contact, which is Keith Leonard. And so Keith is going to talk about the specifics of this call.
Okay, so to give you a little bit more background, I have a few slides before we get into the details of the proposal call. So extension of service life for materials is a very big challenge. There's, you can see on the diagram, you have effects of water, stress, radiation, and then materials issues. But this is, by no means, this is just kind of a simplistic example, but doesn't give you all the possible combinations and some of the synergistic effects. There may also be, as you go to higher fluences, other degradation modes that can come into play that we're just not quite aware of yet. So the goal of the materials research in the LWS program is kind of outlined there in the lower text, and it's to develop a fundamental scientific basis to understand, predict, and measure changes in materials as they age in the reactor environments. And to do that, we look at new methods for monitoring materials, new materials being developed, new technologies, and all in the effort to enhance plant performance and safety. So Rich, can you go to the next slide? So the methodology that we apply is kind of looking at things from three perspectives. One is experimental research, but that's not in its entirety. We're also looking at modeling effects and also relating that back to ex-service materials or harvested materials. So individual paths within the pathway provide contributions to the overall pathway goal through this high-quality scientific measurement of materials performance to understand active modes and mechanisms of degradation. So the dashed lines are kind of near and planned or near-term direction, and it's kind of moving in the center where, you know, if you take, for example, RPV research, we have a lot of experimental work occurring in the program along with modeling work, but we're also involved in the harvesting of Zion RPV materials over this past year. So they'll be kind of worked into the program work scope. So this just kind of gives you an example of some of the methodology that the pathway employs. Okay, next slide, Rich. So to get into the some of the proposed themes of the RC5 call is looking at some of the areas that LWS is interested in and either has not really initiated research on specific subjects or is looking for some kind of a little bit of outside influence or to be able to kind of jump ahead in some of the research gaps. So current LWS activities include mechanisms of radiation-assisted stress corrosion cracking, high fluence predictions, modeling predictions of radiation-induced swelling, segregation, precipitation, effects of water chemistry and crack growth, and environmentally assisted fatigue. But current LWS interests have been mostly aimed at, or most of the research has been aimed at some of the base metal issues. So in this proposed theme, we really want to look at some of the weldment issues, long-term aging effects, both thermal and radiation effects on fracture toughness, on alloy 82, 182 weldments, as well as stainless steel weldments as well. So this just kind of gives the example of some of the issues that we're looking at welds between dissimilar metals, going from the 508 low alloy steel RPV nozzle end, going into the 316 stainless steel piping. So we really want to concentrate on some of the issues that would possibly affect these, and they may be just aging issues, thermal radiation effects, environmental fatigue effects. What is the changes in the property over time? Okay, next slide. Another area, and this is kind of, as you can see, the diversity involved in the materials research. So now we're kind of jumping ahead to non-destructive examination techniques for concrete. A lot of the concrete NDE techniques have really been derived from Department of Transportation area work, but that's involved structures that were less reinforced or very much thinner structures than what are used in concrete or nuclear structures. So improvements in instrumentation and software are really wanting to be developed for these NDE techniques to go beyond the current technology to evaluate very thick concrete structures. So this is kind of looking at what possible current hardware technologies could be developed for structures that are thicker, more heavily reinforced, and also what kind of new technologies or methodologies can be developed in terms of software processing. An example here is shown in the lower right, and this is detection of a piece of 2x4 that was intentionally put in a test concrete block at a certain depth, and using synthetic aperture focusing technique with frequency banding, which is kind of a software technique to help better identify and clean up some of the ultrasonic signal that you're receiving back on the defect that's under deep cover. So we're looking at hardware advances as well as software advances. Okay, Rich. NDE is also continued on in cable issues that for nuclear plants. And there's a wide variety of NDE technologies that are available. Certain methods are used for long length detection or analyzing long lengths of cable. Others are more suitable for specific site location, identification, and analysis. And so we're really looking at what techniques and technologies are really available. For example, frequency domain reflectometry is very useful in showing damaged region or damaged section in a long length cable. But the question is can it be really utilized to evaluate the extent of damage, or do you need to go in and still rely on short segment techniques such as indenter modulus to look at that actual damaged section? So what we're looking at is there any new methods that would be useful in measuring cable health conditions more accurately and more economically to be suitable for plant operations? Okay.
So that's the end of the presentation. So we'll pause now for any questions.
Keith, there's one question. Do proposals to RC5 have to hit all three issues, metallic alloys, NDE of concrete material systems, and NDE of cables?
Oh, no, these would be separate. I mean, these are areas that were kind of identified that could provide the LWS program with kind of a jump ahead or a look ahead at some of the topics that we would like to cover, but just haven't really effectively covered at this time. So it provides an opportunity also for infusion of new ideas into the program as well. There may be techniques that were just that are being developed, such as in the X-ray tomography area or medical tomography areas that would be helpful for the concrete NDE work that's going on.
Are enhanced radiographic techniques of interest in this area?
I don't think they've really been utilized as much. I'm not sure how accurate that would really be effective in measuring to the depths that we're really in need of looking at. It's kind of a penetration issue there.
In the RC5 call, viscoelastic inversion methods for concrete are mentioned. Is this a firm requirement?
No, it's just an example.
I'm going to need to reword that question. Are you interested in other advanced metallic materials other than listed in the presentation?
Some of that's covered in the NEET topic area that I think we'll be discussing in a little bit, and that's looking at some advanced replacement or advanced radiation resistant materials. So really for the metallic portion of RC5, I'm really interested in the weldments.
Does RC5 accept computer modeling projects for predicting irradiation-assisted stress corrosion cracking, or should they go to NEAMS?
I think we'd be interested in looking at it. I don't see any reason why we wouldn't be acceptable to looking at what's being proposed. I mean, certainly when you looked at kind of the methodology approach, we are, looking at kind of, merging, both experimental and modeling in together, and that's kind of one very nice part of the LWS program is that it really effectively does that, much more than some other programs that I've seen or have experienced with. So modeling support is definitely welcome.
I would say that if the focus is on materials degradation and how you can model that, using a computer model, we would be interested in that, the LWRS program. If the focus is on novel methods of modeling that would be more, computer science oriented, that would probably be more interested to NEAMS. If it's not, really focused on the materials itself, but on the methods of modeling.
Are any of the studies for material aging and degradation specific to the advanced test reactor?
Not specifically. What we're more interested in is, are you referring to experiments coming out of ATR, or?
We can get clarification. Okay. We can move on to the next question. Do we need to investigate weldment failure with or without irradiation, or is only one of those enough for the proposal?
Radiation is going to play an important role. How that affects overall performance of the material is important, so I wouldn't necessarily discount it or disregard it at this point. But if a proposal is fundamentally addresses either SCC issues, environmental fatigue issues that could further be utilized for improvements in understanding radiation-induced change, or I should say, how those effects. If they establish the baseline, it's going to be useful to then further develop those for radiation effects. So I won't completely discount it, but radiation is going to play an important role in long-term performance.
To clarify the previous question about ATR, the individual is talking about the reactor itself, not the experiments.
No, I don't see it, no.
Is pre-stressing cables corrosion of interest?
Is pre-stressing what?
Cables corrosion.
Mechanical. Oh, okay.
Steel cables in concrete.
Okay.
Corrosion of the steel
rebar. Okay. It is. It's something that's kind of being looked at a little bit by EPRI, I believe. It's not a major issue right now for LWRS because we're trying to develop understanding of more of the concrete itself, and not specifically yet the concrete rebar or interactions at this point. If it's a technique that allows for, if it's an NDE technique that allows to look at and evaluate, more corrosion aspects related between the two, that would be, I would say that'd be helpful and useful.
Are super alloys considered in this program?
That's really fallen under NEET, and I think we'll get to that in just a little bit.
Are the metallic materials provided for our testing in RC5?
Are metallic materials provided? No.
For radiography and tomography, what kind of spatial resolution is of interest?
Oh, that's a good question. Most of the flaws are going to be, we're looking at kind of more, a little bit larger size changes as far as defects or flaws, not really everything from small changes to large. Yeah. So it could be, on the millimeter size scale on up. So, cracks can be very significant and they're interwoven and throughout the structure, but there's also some questions about whether you can monitor things such as ASR effects, which are a little bit more subtle but can happen a little bit more over a global area.
Is concrete aging still an area of interest, or is it only through collaborations with EPRI and NRC?
Well, LWS has been collaborating with EPRI and NRC on a variety of topics. So concrete is one of those subject areas that there is a lot to be addressed on, and still some uncertainty and unknowns in terms of long-term performance. So it is an area that we are interested in.
Are you looking for specific types of defects or degradation in concrete?
Not specific.
In the RC5 call, 2 specific topics for concrete are listed, one on large structures and one on multi-element ultrasonic array inversion. Are these separate calls?
One is to look at if there's any kind of, one's a little bit more software driven, whether you can model and assess through current technologies, better resolution of defects or changes in the material. The other one is looking a little bit more at hardware changes, what increasing the array size or making changes to the detection system itself be of any benefit.
A follow-up to that question is, on the second call, is that exclusively limited to ultrasonic arrays?
No.
Is technology for detecting and evaluating flow-assisted corrosion and piping of interest?
I'm sorry, could you repeat that?
Is technology for detecting and evaluating flow-assisted corrosion and piping of interest?
Not on this specific call.
Are there mechanical testing facilities available through NSUF which may be used to support work unirradiated materials tested for this program?
Yes, there are locations available through the national labs that are part of the NSUF organization.
Does irradiation refer to neutron irradiation or ion irradiation?
For this particular call, it can be ion irradiation because of the information that's available at this time on weldment or long-term weldment effects on welds. For the other NEET call that we'll kind of go into, that will be a little bit more specific to neutron irradiation.
Are modeling procedures focused on other concrete degradation mechanisms of interest, e.g. creep-induced cracking or ASR-induced expansions?
Yes.
Does SCC refer to crack growth rate test or crack initiation test?
Both. I mean, we're interested in initiation effects and what is the mechanisms behind it, and then crack growth through the material is probably secondary of importance, but still requiring understanding, particularly when it comes to chemistry issues.
It sounds like you would like to see how existing defects in concrete change or grow with time. Am I understanding that correctly?
Not. It is an area of interest to LWRS, but it's not specifically called on the RC5 test.
Is the concrete degradation of spent fuel pool walls adjacent to extreme gamma fields from spent fuel long-term storage included in RC5?
NDE techniques would be useful, but in terms of a specific task area of interest, that is an area that EPRI has been looking at. Where if an NDE technique is really kind of developed to help evaluate that is a definite interest, I think, to the overall nuclear field. So yes, if there is NDE techniques that can dramatically improve detection methods for those applications, then that would be useful.
Is probabilistic modeling in predicting damage progression of interest?
Not specifically on this call.
And the last question we have, I can answer. The question is UK participating in any of these areas for RC5? And we do not yet have information on which areas the UK will or will not be participating in. That information will become available upon or slightly after the release of the FOA.